when looking at data analysis of qualitative, so now we're looking at qualitative values, this is again made up data, like a lot of the data that I use. However, our book does use data that did at one point come from a real place. And when you're out there looking at the real world, hopefully people are using actual real data. But this is a number of telephone contacts, telephone. Now, granted, I know most people text, but anyways, this is the number of contacts you have in your phone. All right. So I simply asked 10 people how many contacts they had in their phone, and this is what they told me. All right, so what we're going to do is we're going to make some quantitative graphs of this data. First one we're going to do is what's called a stem and leaf. Stem and leaf is, I look at the data and say, okay, how can I look at this data and organize it? And there's two different ways. With a 3-digit number, I can either let my stem, which is over here, be a 1-digit or a 2-digit number, and then I have my leaf, which is always a 1-digit number. So what do I mean by that? Well, let me show you. Here's one way we could do this. I could take the lowest number there, which is 330, and make this 33. Ooh, need to make an actual number, 33. And then the number after it would be a 0. And then I would have to go up 34, 35, 36, 37, 38, 39, 40, 41. Do I have to go past that? No, because my largest one is 415. Extend this line down. And okay, are there any numbers that start with a 3 and a 4? No, there's not. So I'm going to go up here and I'm going to cross off. So I just did 330, which is this one. And then I'm going to do the next one up, which looks like it's 385. So on the 38, I put a 5. And then on the 39, I've got multiple ones. So I start with the lowest one. So 39, 1, 39, 5, and 39, 9. Biggest word of caution is that when you're doing this, you got to make sure that the first numbers after each lineup, and then the second numbers after each lineup, and then the third numbers after each lineup. So I did 391, 395, and 399. And then I've got 40s. So I've got 402, 403. Again, it's lined up underneath the 5. All right, so that's 402 and 403. And then I have 409. And then I've got 41, 0. 41, 5. And I should then have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All 10 of my data points, and that's how I could do a stem and leaf plot. There are other ways to do it, but that's the one that probably makes the most sense for this kind. And then I need a key. I need to say somewhere what's going on. So I got like 385 is equal to 385. All right. And that's how I do a stem and leaf. And there's different ways, and we'll look at different ways to do that depending on the types of data that you have. Now, if I had another set of 10 data points, and maybe this was for men, for guys that I talk to, and maybe I'm going to do another 10 and they're going to be for women, I would do this over here. And I'd sample another 10 or so, and then I'd plot them, and this then would be a back-to-back stem and leaf plot. Okay? Stem and leaf plot. I could then take that data and make it into a histogram. And so here I've taken some arbitrary widths. So I'm going from 330 to 340. So each of them are the same. So you got to make sure that when you're doing a histogram, the width, sometimes called the bin width, is the same. So they're all differing by 20. And then I say, okay, well, how many were there between 330 and 340? So I've entered some of this in here. So I went back and I looked, and you can too. Between 330 and 340, there was one data point. And then from 380 to 400, well, there was the 385, and then the three of them, they were in the 390s, so that means a grand total of 4. So this one goes up to 4. That's a 4. All right. And then how many were in the 400 to 420? There were a total of 5. So I need to make my next bar go up to 5, and then over, and then down. All right, and here I have then a histogram. Now, again, I can change these widths to be other things, and that will change a little bit of how this graph looks. All right, so now I got to describe this graph. So I'm going to what did I do there? Anyways, I will describe this graph using those words that I said earlier, which are shape, center, spread, and outliers. We will say this phrase a lot of times shape, center, spread, outliers. And we're going to learn all sorts of different shapes. Is this shape of this distribution symmetric? No, it's not. It's not the same on both sides. Then there's, let's see, if it's not symmetric, is it uniform or constant? A uniform or constant graph would be one that goes across, so it's the same all the way across. So like every interval, it's 2. That would be a uniform or constant graph. So it's not uniform, all right? This graph is what's called left skewed. It's called left skewed because a lot of the data is on the right side, and then there's one data point that skews way out here to the left. It's called left skewed. Sometimes, watch my cursor, it'll look like this. It'll go up and then come down way far to the left. All right, and I'll draw some pictures here in a second. So this graph is, for the most part, left skewed. It's centered at, well, center, it'd be the middle value. So if I count, remember there were 10 data points. There's 1 here, and there's 4 here, and there's 5 here. So the middle data point is somewhere actually right on this edge, because there's 5 here, and there's 5 here. So the center is right about 400. So I'd say, since there are 5 data points below 400 and 5 above 400, the center is at approximately 400 contacts from my cell phone list. Spread, most of the data is centered around the 400, with 9, with one possible value that's really low compared to the others that may be a potential outlier. All of this goes into how do we describe data. We're going to do lots more practice, so let's follow along. Shape, center, spread, and outliers. So there's no context here. We don't have percentages or values or anything on here, but we can still do some describing. All right, so shape, this distribution is still not symmetric, so I'm not going to say anything about symmetry. But this one now, a lot of the data is on the left and slopes down to the right. So this is what we would call right skewed. So this histogram is right skewed. And it looks like the center is somewhere right around here. That would be about half of the data is below it and about half of the data is above it. So that would be the median. Median is half below and half above. In class, we may have already done the average, and the average is the mean, but this one has a median right about there. The mean, just in case you're wondering, the average would be slightly higher. So right there is about where the mean would be. How do we know that the mean, M-E-A-N, trust me, it says M-E-A-N. How do we know the mean is a little bit higher than the median? Because these high values pull the mean towards itself. All right, it doesn't take much, and you've all taken tests before, and maybe your test average is something like an 88%, and then you have one really bad day. You might have 10 other tests, but that one really bad day when you're like, it was horrible, like you didn't get sleep the night before, maybe your dog died, maybe something happened, and it just was like crazy low. That one value is going to bring the average down a lot because this is very significantly lower, so it skews your average to the left. So in this case, we've got some small value, we have a few, not very many because it's not very tall, really big numbers, which are going to pull the mean or pull the average higher. All right, same thing would happen. Suppose you have 10 tests and they're all right around the 75% range. And then you just have this awesomely brilliant day and you come away with 100%. Okay, that one value is going to be able to have a high influence in pulling your average up. It's an unusual value. So here we have shape, right skewed. We can try to kind of smooth it out there. So it's right skewed. The center we said is right about here, and it all depends on what values we have. We'd actually give the numeric value if we had it. Most of the data is again around here. The further you go to the right, the less and less there is as part of the right skewedness. And there are no values that are very, very unusual. These are a little bit higher, but they're not out of the trend. They follow the trend of sloping down. If all of a sudden we had a number out here, well, that would be a potential outlier because our trend comes up and goes down and then boop, boop, way out there. An unusual value, that would be an outlier, potential outlier. Now histograms, remember, are not a bar graph. Histograms might resemble a bar graph, but they are very distinctly different. Histogram displays quantitative variables. Horizontal axis is marked off with whatever my units of measurement are. So in the last one, it was a number of cell phone contacts. It's something measurable. A bar graph These are qualities that go along in here, so qualitative. Histograms typically have no space unless there's no data. If there's no data here, then there's a space. Otherwise, there are no spaces, whereas in a bar graph, there are spaces because it's qualities. It's like brown hair, red hair, blonde hair, whatever other colored hair. You can't have, you either have brown hair or you have blonde hair. If you want to say that there's another shade in there, and say, well, it's a light blonde or light brown or something like that, well, then you make another category for light brown. But you cannot have someone who has the same exact color hair in two different categories. That's just not possible. It's like saying someone's eyes are both blue and brown at the same time. Genetically, it might be possible to have one of each. I don't know the answer to that. But when in doubt, though, when we're making comparisons, especially when we're going to start doing back-to-back comparisons or comparisons between boys and girls and other things, we want to make sure that maybe we're looking at relative distribution, so percentages instead of just sheer count values, because they might tell us more. So really quickly here, let me do different shapes of graphs. All right, so if we have a graph that's like this, definitely symmetric. It's actually somewhat triangular. If I have a graph like this, that graph is what's called left skewed. Graph like this, high mound and then way out to the right, that's right skewed. I have a constant graph, which would look like this, sometimes called uniform. We'll do others, this one, where if it's evenly spread, and I kind of ran out of room on the side of my page there, do a better one. Like that, that's mound shaped or bell shaped. Those are the most commonly used types of shape descriptions. When in doubt, usually it's going to fall into one of three, either symmetric, so it would be symmetric uniform, symmetric bell-shaped. If it's not symmetric, it's going to be skewed. So this one's skewed left, this one's skewed right. And if I were to draw it in, let's see, this would be the median, this would be the mean, the average, because these high values out here, so this is the median. And this is the mean, and the mean is often using the Greek letter mu. In this one, there's the, well, yeah, that's about right. That'll be the median. There's going to be the mean. In this case, the mean and the median are the same. In a symmetric distribution, the median and the mean are the same. Same thing here, same thing here, same thing here. They're awfully close to the same exact value. All right, and again, how do we know this? If it's skewed to the right, that means the mean is skewed higher than the median to the right. Here, the mean is skewed to the left of the median, or that's why it's then called left skewed. In the next video, we're going to be starting to talk about numeric ways to describe data. So far, we've only talked about, in this video, mostly just graphical ways to describe data. And we talked about the stem and leaf plot. A couple videos, I think I hit dot plot. I've not done the box and whisker plot, although it's coming up soon. In the review, in the portion of your reflection analysis page that I want you to fill out, in the question I'm asking you is, what do you remember about the box and whisker plot, or just a box plot? Some of you may have seen it in your mathematical past, some of you might not. But if you remember something, write down what you recall of a box and whisker plot. That is all. We'll see you later.